Okay, he's not there. Anyways, we move to 6. Oh, he's back. Oh, I thought you had a question. Right. 6 is an easy one. Differences between TLS and XML in terms of security. Okay, so it says outline the main differences between those two, and then the $1 million question is explain why XML is particularly suitable for the role it plays security-wise in terms of these differences. So think about security. Okay, though, if you look at your screen, the main differences between those two, transport layer security and accessible markup language security, is that TLS, now as the name suggests, transport layer security, provides a means for secure transmission of information. This is concerned with the transport layer, transport layer, right? So it provides means for secure information or secure transmission of information, whereas XML security applies the security measures to the document. It is you who's going to use that language to secure those modules. Okay, so you see the difference? TLS is automated. XML is user related. Okay, right. So XML is a self-defining format. Obviously, this should be obvious, enabling security to be applied within a document. It is extensible, which is an architecture designed to accommodate changes done by the user himself or herself, allowing security measures. You can tailor those security measures to be added as requirements evolve. So people, can you see the difference between? I think it's clear. That's why I said it's an easy question. That's the difference between TLS and XML in terms of security. Excuse me, in terms of security. Number 6, do you have a question on 6, people? Okay. Seven, back to security, XML. So if XML can protect those documents, it says documents protected by XML security may be signed or encrypted. Signed, i.e. digital signature. Okay. Long before anyone can predict who will be the ultimate recipient or recipients. So the question is, what measures are taken to ensure that the latter have access to the algorithm used by the former? So how come those ultimate recipients can decrypt whatever encryption is done at the sending end? Okay, easy. You have algorithms that are agreed upon. The algorithms are used. In this case, those are specified within the XML. Okay, so that recipients know exactly which one was used for encryption. Okay, or digital signature or signing. Also, in addition to this pre-known negotiation, again, pre-known negotiation configuration, the standard states or status actually of that algorithm. This status must be available to any implementation done by the XML, whether it is encryption or digital signature. Now, this will mean that this standard is static, it's not dynamic. The reason why it says or put emphasis on such status, that the state is static, it's not dynamic, i.e. it is known, you cannot change it, but again it is for that session. This is done per session. Obviously you should know that if it is to be done correctly, it must be static. Otherwise, if it is not, this will mean that in terms of the data propagation time, if things are changed somehow by either party, one of them will be lost. So the reason why it says standard status is to be static, or the standard states the algorithm must be available to any implementation, it means that it must be static. Now the creator for each document at the transmitting end obviously should be sure to use one of the standard algorithms. One might ask, if there is an intruder, how can this to be done correctly? If A is sending data to B using a standard, C as an intruder might know, have an idea about the standard. So he or she, C in this case, can decrypt whatever. This is actually not true, because A and B, once they start the communication, or once communication commences, whatever standard that is agreed upon, it is agreed upon beforehand. So the standard actually is not visible to C. The standard is agreed beforehand. I give you an example. Let us say that between 8 a.m. to 10 a.m. standard A is used. Between 10 and 12 standard B is used. So anything that is sent between 8 and 10 follows standard A. A, or that standard, or standard A, is not negotiated during the session. It is negotiated beforehand. That is why the last sentence, if you read the last sentence, it says the creator of such, i.e. the transmitter, should be sure to use one of the standard algorithms. Should use. Okay? Question 7. Do we have a question on number 7, people? Do we have a question on 7, people? Come on. I can't hear you. Yes, Samala. Okay. Good. Right. Number 8. Now, number 8 is on kernelization, or XML kernelization. It says why, or explain the relevance of canonical, this is a hierarchy, canonical XML to digital signatures, i.e. how that signature is scrutinized. This is what it really means. How to scrutinize the signatures by the use of canonical XML. And then it says what contextual information can be included in the canonical form for security reasons, obviously, security reasons, or for your digital signature. And then lastly is asking you to give examples of a breach. Okay, if things goes wrong of security where the context is omitted from this form or from this canonical form. Let us start with the definition of canonicalization. Now this is standard, or sometimes standardization or normalization, that's other names. This is a process, remember security, this is a process of converting data, of data conversion, that has more than one possible representation into a standard, normal, or canonical form. Put it in one form, one format. Now with digital signature, since it is going to relate to that hierarchy, digital signatures are used to ensure that information content, remember security, okay, has not changed since the document was digitally signed. So after digitalization, or after your digital signature, the content should have the same meaning when it reaches the recipient. So the signature at the beginning, so initially, so the signature is initially generated. You generate just like generating a checksum, okay? Generated using some sort of calculations, just like a checksum, actually, based on the canonical form of the document, start and end, word count, letter count, character count, spaces. There are so many ways, okay, which eliminates insignificant differences. Obviously, differences, if to be included, the whole argument will somehow collapse. So it should eliminates insignificant differences, because this will carry the burden on the bandwidth. Right. So after its transmission, the recipient or the receiving end or application applies the same algorithm to the document, which is in a reverse order, obviously, producing another digest of your signature of this canonical form, and the two are to be compared. The two digests are compared by the use of XORing. If they are different, or if they differ, it means that the canonical form differ, so the document must have been altered somewhere. Okay. Now, as far as the contextual information, the actual information, this consists of the namespaces, which is those are declared, and values of the attributes that surrounds the XML, or a particular XML. In essence, what this is telling you, that parameters are somehow biased towards the particular text to be digitized, or signature digitized. Okay, so the inclusion of context in canonical XML ensures, in relation to the text, obviously, that a particular element cannot be used out of context within the text itself, or in a different context, i.e. with other text. So each one has got, in essence, its own signature. Just like you, when you sign your name, when you use your pen to sign your name, it should be different than my signature or your friend's signature, or I cannot somehow recreate your signature and you cannot recreate mine. This is what this text is saying in essence. Now the way this is done, because different texts has got different count, different parameters. So by this canonical form, obviously the calculation, the let us call it checksumming, will create different result per different text, obviously. So if the context is omitted, the canonicalization element can be placed in a different context. As an example, for example, the value of an attribute for a value for a parameter in the context may be crucial to the document being signed. It might be, for example, the rate or the exchange rate, i.e., this is how you know that the document was manipulated. Okay, the omission of anything will not produce the same checksum at the receiving end. Once it is compared or XOR together, it will produce different results. So you know that a breach has somehow incurred on that document. 7.8. Do we have a question on 8, people? Okay. Nine is just an example. Might look like a puzzle at the beginning, but it is not. Transaction between A and B and C. So what we'll be doing is the following. We have different clients, transactions to be done between them, transactions between them to be done using protocols. Now this protocol is to be called coordination protocol. So 7.9, a coordination protocol could be carried out in order to coordinate the actions, transactions, actions of web services, outline the following, or outline architecture for a centralized coordination protocol, a distributed coordination protocol. Now the difference between the two, think of distances. Think of distances. Right, in each case describe what sort of interactions to be done or needed to establish coordination between a pair of web services. Right, as far as the centralized coordination, we'll start with that. Now a centralized coordination is given as an example. So a particular server would play the role of the coordinator, the master slave. Just think of master slave, okay? And the web services that require coordination, in this case, would send their coordination messages to the coordinator, to the master, or the hub. So let us call the web services A and B, with C being your coordinator, A, B, and C. A and B services C coordinator. In order for the coordination to commence, obviously you have a service in relation to the coordinator. So A asks C to create a new context for coordination, okay, establishing service, okay, which is returned. Then A excuse me, sends B a message. Okay, don't forget that A and B, those are web services. So A sends B a message passing an identifier. Now this identifier includes the following. It is used for coordination, and B communications with C about it, or it communicates a communication between B and C about this message. Now the identifier relates to the service, just a number. It could be a number, it could be any parameter, okay? And B obviously communicates with C about it. It must give that identifier to C so that C can coordinate. So you see, centralization needs a master. In this case, you have C as a master, two slaves, A and B. Okay. Now, one might ask, do you need two services? A client might need two services. Yes, it might need more than two services. Okay. You see, services, you might ask for a service and you might think that you are actually trying to access one service. Actually, this is not the case. When you ask for a service, this service actually is carried by so many other services. So A and B might be or might relate to a service called J. Now, service J is to be asked by the client K. Okay, so A and B might be a good example, just to show you that a client might request a service and the actual service include more than one, C being the coordinator. This is the centralized case. Now, in the distributed case, think about the internet. So you have clients, each participating web service would have a local coordinator. Divide and conquer. If you think about distributed coordination, it is just like centralized coordination multiplied. So if you divide a distributed coordination, you'll see local coordinators. Now, local coordinators work exactly the same like the centralized coordinators. Okay? So each participating web service would have a local coordinator that is to communicate with the set of local coordinators, which in essence would communicate among themselves. So it's a multiplicity of centralized coordination. As an example, let us call the web services A and B and their local coordinators CA and CB. Each has got its own local coordinator. So A asks CA to create a new, obviously it asks its own coordinator to create a new context for coordination, which is returned, i.e. agreed upon. Okay. Now A sends B a message. Obviously it will also need an identifier for the coordination, and B then will ask its coordinator, which is CB, to create a context for it, and that's it. So you see, in terms of distribution or distributed coordination, it is not far from centralized coordination. It is just using the famous divide and conquer game. And that's it. It's as simple as that. Number 9, people. Do we have a question on 9? Okay. Number 10, excuse me, RPC, to be compared with web service reliable messaging. A comparison, again a comparison, a simple comparison. So it says compare RPC, it's called semantics, with the semantics of web service reliable messaging. It says state, now this is the important part, it says state the entities to which each refers to. Now entities differ between the first and the second in accordance to their semantics. And then compare the differing meanings of the available semantics or configuration in this case. For example, at least one, at most one, exactly once. Those are different configurations depending to the different semantics of RPC and WS reliable messaging. Okay, so back to WS reliable messaging. So in WS reliable messaging, now this is a communicating standard, so this is standard for ensuring delivery of requests to the destination services. Okay, so A requests a service from B. B is to receive that request by A through the reliable messaging or WS reliable messaging. Okay, so there is a message exchange between application source and an application destination, source and destination, obviously, and the goal is to provide a given semantic or configuration or meaning over the message delivery. So what are the possible configurations? So the semantics are as follows: at least once. Don't forget, we are dealing with delivery of requests. The name of the game is delivery of requests. So at least once. So the message is delivered at least once with possible duplicates, i.e. somehow there is a mismatch of acknowledgements, so the client or the sending end might resend that request. That's why you have duplicate message. But an error in this case is reported, okay, if it cannot be delivered. So an error report is available here. Don't forget, this is at least once. It needs that mechanism, which is reported. An error is reported at least once. Remember this, at least once an error is reported if it cannot be delivered. That's important. Second, at most once, at most. So the message is delivered at most once with no duplicates. No, there is no duplication, but without any error report if it cannot be delivered. So this is somehow stringent. Exactly once, the message is delivered exactly once, but an error is reported if it cannot be delivered. So obviously this is exactly once. If there is an error, it must be reported. This is from the web service reliable messaging side. Now for the remote call procedures, think of Java. Now this is a protocol, as you know, service request, which is made from program locator and another computer. Now, as far as RPC call semantics, there is a two-way interaction, just like handshaking. Remember handshaking? Between the client and server, with client sending a request, the server on the other end, the server executing the remote procedure. Okay, and the server sending a replay back to the reply back to the client. Right. So these semantics, as far as those configuration concerned, those must be defined in accordance to this mechanism, or in accordance to the RPC procedure or configuration. So in terms of at least once, and here is the difference between the one above, the client receives a result, in which case the request procedure is executed at least once, okay, with possible duplicate executions, or, and this is a big or, receives an error with no result obtained. Okay, so a little bit different than the one above. At most once, this is not that different. The client received a result, so the client receives a result, in which case the requested procedure is executed at most once, okay, with no duplicates, just like the one above actually, but possible failure in executing the procedure is probable, okay, or receives an error with no result obtained. So it is a little bit similar than the one above, okay, about 60% or 70% similar. The last one is different as compared to the above, exactly once. So exactly when the client received a result, so the client receives a result, in which case the requested procedure is executed, okay, exactly once. Here you have no duplicates and no failure part way through, i.e. it is not dealt with, or receives an error with no result obtained. Okay, so it is a little bit different than the one above, i.e. if you compare, if you were asked, this is an example, if you were asked in a question to compare the at least once, at most once, exactly once between the WS reliable messaging and the RPC, at most once, in both cases, they are somehow 70% alike. The other two are not. Okay? Just in case if you were asked in an exam about the differences between those two. Right. Number 10. Do we have a question on 10 people? Don't fall to sleep. Do not fall to sleep. Just answer me. Do we have a question on 10? Nima, Samala, come on, I'm not going to call you by name. Right. Do you have a question on chapter 7? Do you have anything on chapter 7? Okay. Now, if you do not have a question, you may leave. Again, I'm not leaving until the last person leaves. Okay? So if you have a question, do stay on. Else, you may leave. I thank you for attending. I wish you good night. But I'm not leaving until the last person leaves. Excuse me. Okay, Kuta. Okay, Kim. Okay, Nima. Thank you, people, for attending. You've been great. I will see you hopefully next week. Take care. Bye-bye.